solve this guy. Okay. Okay, so if both are on, so you have here 0.7, you have here again 0.7. So you can get VO from either VA or VB, that's fine, from any branch. So for example, from this branch, this means when you have a 0.7 here across DB, this means that this point is higher than this point by 0.7. So VO equal to 5 minus 0.7, 4.3 volts. Very easy. Okay. And you can do the same from this branch as well, the DA branch. Again, DA has 0.7, so this is higher than this by 0.7. So again, 5 by minus 0.7. Okay. Okay, so let's go to 2. And of course, you can check. So you can, for example, get the current. The current I is equal to 4.3 minus 0 over 1 kilo ohm. So it's 4.3 milliamperes, which you will use later in this example. Good. So let's have number 2. Number 2, what we have number 2, when VA is equal to VB is equal to 0. What is Mr. VO? Okay, now we have zeros here. Okay, so the diode to be on, it needs 0.7. Now there is no source in the circuit that can give this diode the 0.7. So probably it's off. So either DA or DB are off. Okay, so currents are zeros. So I is also 0. I, which is 0, equal to VO minus 0 over 1 kilo ohm. So VO is equal to 0. Okay, so good. Question number 3. VA is equal to 5, VB equal to 5, VB equal to 0. Again, what is VO? So if VA is equal to 5, and VB is equal to 0. Actually, I know I don't need to mention that VB is equal to 0, because whenever you have a voltage input, either VA or VB is equal to 5, then its diode will be on. So in that case, DA is on, DB is off. Okay. So again, now this branch, you don't know what is the voltage on DB. So we have to find VO through the DA branch only, this branch, this one, between these 2 points. So VO again equal to VA minus 0.7, the voltage drop across the diode, DA. So this will be equal to 5 minus 0.7 equal to 4.3. And you can show easily whenever one of the inputs is 5, then the output is equal to 4.3. Okay, so again, this should be 4.3. Then question 4, when VB is when VB is equal to 5, what is diode, the situation of diode DB? So we just mentioned it, okay? I said that whenever you have, oops, there's something wrong with, whenever you have an input with 5, then its corresponding diode will be on. So in that case here, when you have 5 on VB, then DB is on. And on means it's forward. So DB will be forward and on. Okay. Question 5 should be similar. When VA is equal to 5 and VB is equal, actually, I don't need to mention the situation of VB or VA, but anyways, so when VA is equal to 5, VB is equal to 0. Again, what is the situation of the diode dB? So let's go back here because we have this. Yeah, we have it here. So we have the situation here. In this situation, dA is on, dB is off, okay, and VO is 4.3. So let's calculate VDB, the voltage across the diode B. It's equal to, if we go back here, the diode is a tablet is went is crazy. So VDB is equal to this voltage VB minus this voltage VO. VB is equal to 0 and VO is 4.3 volt. So VDB equal to minus 4.3. That means the diode is reverse. Reverse. So here the diode dB is reverse bias, and of course, and not breakdown, because its voltage it's only minus 4.3. The voltage breakdown is minus 100, as I mentioned in the beginning of the question. Okay, so it's not breakdown as well. Number 6. So in number 6, what we have, when VB is equal to 5, what is the current I? So I don't need to mention VA in here, because whenever one of the diodes is on, okay, then VO equal to 4.3. So I is equal to 4.3 minus 0 over 1 kilo ohm. So 4.3 milliamperes. Number 7. When VB is equal to 5 and VA is equal to 5, what is IA? So both VB and VA is equal to 5. So both diodes DA and DB are on. Okay, so VO is 4.3 volts. So I is equal to 4.3, I'm sorry, 4.3 milliamperes. And I equal to IA plus IB. If you go back here, so this is IB and this is IA. So IA and IB is going into the node, this node, and the I is going out of the node. So I is equal to IA plus IB. And since the diodes are identical and both are on, so the current I will be divided equally. So this is equal to 2IA or 2IB. Okay, what is required here? It's required IA. So IA is equal to I over 2, 215 milliamperes. Number 8. Which logic this circuit represent? So the logic. So yesterday's quiz was AND gate. So I told you in the lecture I will ask something in the homework, then the quiz will be the second one. So without solving the question. So the homework was AND, so this should be OR. But we can do it. So we can write VA and VB and Mr. VO. So 0, 0 give us 0, as we mentioned before. 0, 5 give us 4.3. 5, 0 give us again 4.3. And 5 and 5 give us 4.3. And this is, can be told with as such. So this is A, B, V, O, or O, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. This is OR gate. Okay? Okay. So that's the quiz. I hope it's clear. Now, if you just messed up with the quiz, that's fine. Okay. Now study it again and please do the homework. And if you can resubmit the homework, because some of you in the homework 9, get it wrong. For some reasons, they didn't get